This is section 12.1, tangent lines. Definition of a tangent line is a line that intersects a circle at exactly one point, and it is indicated here by the red dot on your screen. If a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. Remember, a radius goes from the center of a circle to the circle's edge. So anytime you have a tangent line where the tangent line intersects the radius, those two form a 90-degree angle. So if it were over here, this would be 90 degrees. Some examples uses what you were just told. The idea that if you have a tangent line and it does continue extending forever, and a radius from here to here, those two form a 90-degree angle. You now have a triangle. Triangles add up to 180 degrees. So 180 degrees minus the 38, and you can find the value of x. Second one, I'm asking, is AB tangent to circle C? So what we're trying to decide is, does the tangent line form a 90-degree angle with the radius? So we need to verify that that is indeed a 90 degrees, a 90-degree angle. We'll use the converse of the Pythagorean theorem that states if a squared plus b squared equals c squared, then you know you have a right angle. So let's try it. 17 is the longest leg, so it must be the c squared. So I'm going to try 8 squared plus 12 squared, and I'm going to check if it equals 17 squared. 8 squared is 64, 12 squared is 144, 17 is 289. So it adds up being 208 equaling 289. That's not true. So this is not a right angle, so AB is not tangent to circle C. Another key concept. From point T, how many lines, how many tangent lines do you think you could draw to the circle from point T? The answer, 2. You could draw one to a point on top of a circle and one to the point lower on the circle. What I need you to know about drawing tangent lines from a point T outside of the circle to the circle is that both the length from T to the circle, let's call it A, and the point from T to the circle down here, let's call it B, are the exact same length. So two tangent segments drawn from the same point outside a circle are congruent. So what we need to know then is that the length of TA is equal to the length of TB, or segment TA is congruent to segment TB. Now let's use that. So this example is asking, what is the perimeter of the triangle? Well, we have several different segment lengths. All right, so for a moment, let's call this A, this one B, and this one C. The value or the length from A to the circle and from A to the circle over here need to be the exact same length to fit with the explanation I just gave you on tangent lines. So from A to the circle over here is 6 inches. It must also be 6 inches on the other side. Since the entire side length AC is a total of 9, some of it is 6 inches, the other part must be 3. Look at C. Point C goes up to the circle in 2 different places. So 3 inches on one side, 3 inches on the other because they're congruent. And lastly, from point D, or I'm sorry, from point B. From B to the circle and from B to the circle, they need to be the exact same length. We have 8 inches from C all the way to B, where part of it is 3 inches, so the other must be 5, and its congruent length must be 5 as well. Add up all those side lengths. So this length of 9 plus this length of 8 plus this length of 11 should end up giving you your perimeter, because perimeter goes around the outside of a shape. Take a moment, pause the video, and try the following 3 problems. For problem number 1, because we're dealing with tangent lines and radius, the 2 angles marked must be 90 degrees. This is now a 4-sided figure. So 360 is the total number of degrees in a 4-sided figure. So 360 minus 90 minus 60 minus 90 gives you your value of x. Problem number 2, this one's telling you that the entire perimeter adds up to 88 degrees. Recognizing from point P to x and then point P to z is the same length, so they must both be 15 centimeters. R to z and R to y are the same length of 17 centimeters. I'm going to add up what I have, subtract it from 88, so that I can determine these 2 missing lengths, which also are the same amount. So I'm going to add up these ideas, which is 30, plus these 2, which is 34. And I don't know what those are, but I know that there's 2 of them. Together, all of that needs to add up to 88. When I combine like terms, subtract things to the other side, I get that 2x ends up equaling, well, this is 64, so 88 minus 64 is 24, x equals 12. Both of these lengths have a measurement of 12 centimeters. Lastly, okay, last problem is labeled challenging. This problem says find the value of x to the nearest hundredth. We need to recognize that the length labeled x is the radius, and that the length labeled 10 is the tangent line, because it's intersecting the circle at one point. Meaning, if those 2 are, if the tangent and the radius intersect at the point of tangency, we should have a 90-degree angle. Using that, we're able to find the value of x. We'll use Pythagorean theorem, which states that a squared plus b squared needs to equal c squared. And here, it's a length of 7 centimeters added to an unknown. So it's going to be x plus 7 squared. You're going to be tempted to want to distribute the exponent of 2 to the x and the 7, but it doesn't work that way. Think about Algebra 1 for a moment. Exponents tell us that there's repeated multiplication. So this is letting us know that we have x plus 7 times x plus 7. Double distribute. X times x times 7, 7 times x, and 7 times 7. When we combine like terms, we're left with x squared plus 14x plus 49. So x squared, let me fix that mistake here real quick. That should be 10 squared, and 10 squared is 100. And it equals x squared plus 14x plus 49. I'm going to start by subtracting my x squareds. Luckily, they cancel. I'm going to next move over the 49. 100 minus 49 is 51, and it equals 14x. Divide both sides by 14, and x equals a decimal here, I ended up with 3.64 when rounded to the nearest hundredth. If you'd like, take a second and check with your 3.64. Remember that because it's rounded, it may not all add up exactly. So if you were to plug the 3.64 here, square it, the 3.64 here, add it to 7 and square it, they should equal a very similar amount. Try some more. Turn the page. The next page is asking you, or telling you, that segment PA and segment PB are tangent to circle C. Asking you to find the value of x, the perimeter of the quadrilateral, and the length of segment PC. Pause your video, try those problems. Because PA and PB are tangent to the circle, at the point of tangency, I know that angle A and angle B are 90 degrees. Because the angle measure of a quadrilateral is 360, if I add all those angles together and subtract from 360, I'm left with 87.2. Find the perimeter of quadrilateral PBCA. C to B is a radius, so C to A is also a radius. From point P, P to A is a tangent line, P to B is a tangent line. But because they both originate at point P, they are congruent. So 20 plus 20 plus 21 plus 21 is 82 centimeters. Lastly, to find the length of P to C. P to C is here. And we know that there's a 90-degree angle. In the previous problem, I had labeled 20 degrees. No need to mess with any of these angles. They are not an issue in this problem. We have a 90-degree triangle, right triangle, with a 20, a 21, and we don't know what that value is. I'm going to go ahead and use Pythagorean theorem. 20 squared plus 21 squared equals x squared. That gives me 841 equals x squared. When I square root that value, I'm left with 29 centimeters. This concludes the video for section 12.1. Do your best to attempt the worksheet on the next page. The answer key is online, and you will have your MathXL mini quiz. Thank you so much. Please let me know if you have any questions.